Um, okay. Hello everyone. Let me introduce myself. My name is Putri Angel Saragi with student ID number 123490006, majoring in instrumentation and automation engineering. In this video, I will be presenting assignment 5 for the Web and IoT Programming practical course, and the assignment is create a 20 minutes explanatory video on the topic of JSON data exchange, covering the definition of JSON, how to read and write JSON on the client side, um, like HTML and JavaScript, and a simple example of data exchange between the web and IoT device. And case study in the video explain the program workflow and show a demo of the result. Upload the video to YouTube with public access, or anyone with the link can view it. Um, First, we can discuss about um, definition of JSON. In here we have one PPT introduced about JSON. JSON of JavaScript object notation is a lightweight data interchange format that easy for humans to read and write, and easy for machines to parse and generate. It is mainly used to exchange data between a server and web client, or between different devices and systems. JSON represents data in key-value pairs and support data types such as strings, number, arrays, object, booleans, and more. Because it is text-based and language independent, JSON has become one of the most popular formats for data exchange on the web and in IoT applications. Second, we discuss about reading and writing JSON on the client side. In web development, JSON is frequently used in client-side programming with HTML and JavaScript. JavaScript provides support in method to handle JSON data, like code JSON.parse is used to read or convert a JSON string into a JavaScript object. Um, and then we have JSON.string v, is used to write or cover a JavaScript object into a JSON string. For example, if you retrieve data from a web API, you can use fetch in JavaScript to get the JSON response and then use JSON.parse to process it. Conversely, when sending data back to the server, you can use JSON.stringv to convert your data into JSON format for sending it. Then we can discuss about the program. A simple example of JSON data exchange can be demonstrated between a web page and an IoT device such as a temperature sensor. The IoT device collects temperature data and send it to a web server in JSON format like this. The web application can read this data using JavaScript, display in real time on a dashboard, or even send comment back to the IoT device in JSON format. This is a two-way communication and ensures that both the client or web and device or IoT can understand and exchange data efficiently. Next, in here we have a program. In here I have one program, and this program is designed to run on a ESP32 microcontroller and function as a single web server that provides sensor data in JSON format. It is connects to a Wi-Fi network. In here, um, I have a server view for the Wi-Fi network. It connects to a Wi-Fi network. Its temperature data from a TH18B20 temperature sensor and light intensity data from an LDR sensor. Then send this data as JSON response through a web API endpoint. In here we have library imports. The library are essential for the following functional. My Wi-Fi.h is the function is connects to ESP32 to a Wi-Fi network, and then webserver.h. This is creates and manage an HTTP web server on the ESP32. And then Arduino JSON.h. The function is allow easy creation and manipulation of JSON data. And last, one wire and the temperature is handle communication with the TS18B20 temperature sensor, which use the one-wire protocol. In here we have Wi-Fi configuration. The lines define the Wi-Fi credential. The ESP32 uses these values to connect the specific Wi-Fi network. Make sure the SSID and password are correct for your local network. And then we have sensor configuration. In here, the TS18B20 is connected to GPO pin 10, and the LDR or light dependent resistor is connected to analog input pin 5. Then the one wire and the temperature object are initial. This object allows the ESP32 to communicate with and read data from the TS18B20 sensor. Next, in here we have web server initialization. This line creates an HTTP server on port 80, or the default port for the web server. Clients like web browser or JavaScript apps can send requests to the server to retrieve data. And then root throat handler, void handler in here. When a user visits the ESP32 IP address in browser, like e.g.http dot measure 192, and then when this function returns a simple message confirm that the server is running. And then in here, this function one read sensor data. This function is request temperature from the TS18B20 and reads analog data from the LDR. Number two, build JSON data. This is stores the value in a JSON document with key device, suhu for temperature, and LDR for light intensity. And then we have serial JSON. The function is convert the JSON document into a string for transmission and send the response. Return the JSON data to the client with upper HTTP header and parse or cross-origin resource sharing, allowing requests from any domain. A sample JSON output might look like JSON. And in here we have void setup function. The setup function performs the following step: is start serial communication for debunking, connect the configured Wi-Fi network, and then prints connection status and assign a IP address, and then initial the temperature sensor, define two routes for the web server like returns text message or return sensor data in JSON format. And once we can start the web server, and then in here we have void loop. This continuously listen for and handles incoming client's request when a user visit or data the appropriate handle JSON. Handle thread or handle JSON is called. To summarize, JSON plays a crucial role in modern web and IoT system because it provides a simple yet powerful way to exchange data across platform and technology. Understanding how to read, write, and implement JSON-based communication enables developers to build flexible and scalable applications that can connect various devices and services seamlessly. Okay, in here I have the result of the measurements which are scheduled of yesterday experiment. In here, we can see the device in the pressure sensor and measurement of temperature is 27.5 and in units Celsius.